Hello class, how are you all? I hope that you must be doing very great at your places. Class, in the previous lesson, we had discussed hydrogen bonding and we learned that when are hydrogen bonds formed, how they are formed, and what are their unique properties. With the help of examples, we came to know that there are few very highly electronegative atoms. Whenever they are bonded to hydrogen, the unequal distribution of bond pair of electron between hydrogen and that electronegative atom results in the formation of dipoles in the molecule. This is how the hydrogen becomes slightly positively ionized, and this hydrogen is attracted by the neighboring electronegative centers, and this is how all molecules are inter-attracted or inter-bound. Now in today's class we are going to apply hydrogen bonding on properties. So we see why hydrogen bonds are very important in some of the properties of compounds. So we begin with thermodynamic properties. You know that all compounds have their sharp and fixed characteristic melting and boiling points. So here we are going to study the boiling points of compounds in which hydrogen is must. Whenever hydrogen makes compound with another element, it is called as hydride. So we see here we are studying the boiling point trends of different hydrides from the periodic table. And you see the graph is plotted, the boiling points on the y-axis and the period number, which is the row number in periodic table, is kept on the x-axis. Now we see the graph of period number 2. It begins with carbon. Carbon's hydride is methane. As we go in a period, there is a gradual increase in boiling point. This is same for period number 2 and 3. But here we are also looking that the compound water in which hydrogen is bonded to oxygen, the compound HF, hydrofluoric acid, in which hydrogen is bonded to fluorine, and the compound ammonia, in which hydrogen is bonded to nitrogen. All these compounds have their unexpected high boiling points, and these unexpected high boiling points are just due to availability of hydrogen bonding. So this is how, due to hydrogen bonding, due to more and strong hydrogen bonding, the boiling points are always high. Now when we compare the boiling point of water and boiling point of hydrofluoric acid, we know that fluorine is the most electronegative element of the periodic table. So we should expect that the boiling point of HF must be higher than that of water, but it is not practically possible because the boiling point of water is much higher than that of HF, because water molecule has 2 hydrogen bonds. So more and strong hydrogen bonds are present in a water molecule. So again we see the other property is the solubility. You know that the compounds become soluble and miscible just on the basis of their intermolecular forces. and water is called as the universal solvent just due to its dissolving power, and water becomes the best solvent due to its hydrogen bonding system. Next, we see ethyl alcohol is also having hydrogen bond, because in a molecule of ethyl alcohol, oxygen is bonded to hydrogen. Similarly, carboxylic acids are also soluble in water just due to hydrogen bonding. But on the other hand, we see hydrocarbons, means compounds of carbon and hydrogen, are non-polar in nature, and that is why they are insoluble in water, because water behaves as a polar solvent. It cannot dissolve any non-polar material in it, because no hydrogen bonds are formed between water and hydrocarbons. The third very unique structure of ice. You see, one molecule of water is shown here, and you can see that the water molecules are especially shaped into its tetrahedral structure, means each water molecule is attracted by four sides. So this is how the ice has, when we freeze liquid water, it becomes ice, but the density of ice is lower than that of water due to this open structure of ice. And you know that there are two lone pair of electrons are also available on water molecule, and they are on oxygen atom. So this is how the water molecule can attract four sides. It gives us tetrahedral structure. The fourth property is the cleansing action of soaps and detergents. You know, soaps and detergents wash our clothes and our other materials, our houses, everything. And their performance is just because of the polar part of their molecule becomes soluble in the water just due to hydrogen bonding. The fifth property is hydrogen bonding when we see in biological compounds and other food materials like the protein. You know, the proteins are building blocks of life or living things, and proteins have amino acids as their monomers, as the simplest molecules, and in these amino acids the oxygen is also present and nitrogen is also present, and these two centers become the centers of hydrogen bond, and the open chain structure is turned into a helix like this, and these units are linked by hydrogen bond. That's why its helical structure is present or spiral structure is present. We see the same thing is happening in the molecule of deoxyribonucleic acid, yet it is the DNA. It is found in the chromosomes, the nucleus of a cell, and they perform very important part in the genetics. They pass on the properties of one organism to its next generation. So we see that these special protein molecules are linked together by hydrogen bonds, and these dashed lines are hydrogen bondings. So they are binding two helical together. So it's formed as the double helical just because of these intermolecular forces of hydrogen bonding. The sixth application is very, very fascinating. We see the cotton, silk, and other synthetic fibers are very rigid and very tough, or their strength is due to the unique hydrogen bonding. And when we use glues and dyes and paints and emulsions on the walls or on the furnitures, they become sticky to it. And this adhesive nature or this sticky nature is again none other than hydrogen bonding. So we see that very smaller atoms are playing very big chemistry for us in our daily life, and we are using these properties to make our life easier and comfortable. Today I have winded up hydrogen bonding topic. You understand it, you watch the video, read the topic thoroughly from the book, then learn it. Thank you class. Take care.